Hey, what's up, everybody? I thought I did the intro. I was like, oh man, let's get started. Louis, Zariah, good to see you here. What should we do first? Should we do the data analytics? I think we could do the data analytics, right? Oh my gosh, data analytics. Woo! Let's do it. Data analytics. Get ready. Okay, data analytics assignment. Where is data analytics? Data analytics. Regression. How's everyone doing in the chat? Chat can hear me and see me, right? We're live streaming, right? It says streaming. There we go. Okay, data analytics. So data analytics 5, regression. So with this week's, for me, I'm confused about the random sample start. Yeah, let's take a look at that. So here's the getting started part. When you get started on this, what should you always look at for how you're graded? Always look at the rubric. If you have disagreements with how you're graded, if it's not graded by the rubric, you let us know. We'll do the random sampling part here to start in just a second, but please, when you are doing this, look at like statistical significance interpretation, properly interpret statistical significance, AI reflection, you need to do that. R-squared interpretation, blank percent of the variation y explained with the variation x. Slope interpretation, for each one unit increase in x, we expect y to increase or decrease by b1 on average. Y-intercept interpretation, when x is equal to 0, we expect y to equal b0. We'll be going all through this a little bit slower, but these are the ideas. QQ, straighten up, no outliers, plot doesn't thicken. Regression output, make it, and random sample. So if you notice, there's things you need to do for each one. We're going to go through it more slowly, but check the rubric. And then if you don't feel like you're graded fairly by the rubric, let us know, because you should be graded by the rubric. So once again, I will not do exactly this assignment because then I'll be doing the assignment. I'm going to do kind of close to the assignment. So gravy train motors. Let's download your file here. How you doing, Joshua? I had one of the nature-made protein bars. I'll just tell you, these things always make me cough. I don't know. Excuse me. Sorry there. Sorry, coughing in my shoulder. I always I don't know what it is. They taste okay, but they're like chalky or something. I will not endorse nature-made protein bars. You need to stop buying them. They're on sale. Don't buy everything if it's a sale. Okay. So I think we've done a little bit differently this time, but let's take a look right here. Let's put here, take in a random sample. 543, data analytics number 5, taking a random sample. Why do we have you take a random sample? Who knows in the chat for some points? Why would we have you take a random sample? So why are we going to have you do this? Who knows why we're having you do this? Who knows? It's already got the rand. We've already got it in there for you. Frankly, probably it's going to auto-generate each time. Is there still random numbers? Why do we have you take a random sample? Why? Very important. So everybody, when they do the assignment, does unique work. We want the work you do to be different from the work someone else does. So you notice all these points right here. Now, what you should be able to do, and I guess I could kind of just do it for this one, is what you want to do is sort these numbers. There's one way of doing it. So let's go to data, and let's go to sort, and it's going to expand selection. Now, the reason I sorted one time is it regenerated the random numbers. We do want to make sure your numbers, if they look different from mine, you've done it right. Did everyone hear that? You need to make sure you have different numbers than us. I'm wondering if when it pulls up the file each time, if it'll randomly generate the numbers. Let's actually take a look at this right here. Here, we'll undo that. I think it was, okay, 0.57. So don't save. Now let's try and open up the file again. I want to see if everyone's getting a different number every time we reopen this file. We are! Look at that. 0.72. Yay! Okay, we can take out a step then, because I think we, all right, 0.50, okay. Okay, random number generation doing its thing. Generating a random number here. You know what that means? What you can do, as long as these numbers look different for you than what I have. If you see the exact same numbers I have, we got a problem because you're going to get the same random sample as me. What I'm going to do right here is I'm going to click Control C, and then I'm going to hit paste and paste special, paste the values. So we're pasting the values right here. And then I like to sort my values. So then we're simply, after pasting the values, I'll repeat those steps again. All I did was click column A, click Control C, and then paste with right click and paste special paste values. This locks in the values here. So notice it's no longer a formula, it's actually numeric values. Click the column again now, and then go under data and sort the values, expand selection. So now you've got it sorted. Doesn't matter if you sort low to high, high to low.
It doesn't matter.
Doesn't matter. Random sample sheet right here. We need the ID, the mileage, and the price. So all we're going to do is grab these columns right here, hold Shift, and click over, and grab these columns. I'm going to start using another data set here in a second. Doesn't matter if you change the name of the columns or the coloring at the top, but you should have these columns, and your numbers should look different. One last thing that we didn't do that's going to be very important, and I'm glad my brain suddenly said, wait! We didn't take 200. To take 200, you can just go and remove everything past 202, because you do not want more than 200. So if you've done this properly right now, so I held Shift to select more rows, you should see 201 rows, because in the first row, there is going to be the column headers, the names of the columns, and then you should see numbers that are different from mine, and they shouldn't be the same numbers at the start. So you don't want to see the original numbers. Well, if I keep hitting back, it'll undo it. You don't want to see the numbers. We won't save this. Here, we'll open it one more time. If your data looks like this right here and I think we're having you give ID, so the graders will be easily able to tell if they see the ID, but don't just change the IDs because then we can know the data. We want to see randomized IDs. So once again, you can sort this right here. And frankly, because of the way it works, I am pretty certain, this is the last thing we'll say about it, I'm pretty certain if you just go to sort on this, it's going to randomize it. It's actually that easy now. You see, every time I do this, I'm just randomizing it. Notice how the ID changes? It's that easy. Just click the column, sort, grab these, and go over here and paste in the top. But once again, you need the first 200. So if you want, you could click here and then scroll down to 202 and click the end of 201, because we're deleting past 202. So you could do that and just make sure you have down there to 201, because that's 200, because the first row does not have data. And if you've done this, you've made your random sample. So now we've got a little bit of the assignment done. We should also mention that you need to put the information at the top of the document, as you've usually done. I don't think many people lose these points, but you need to grab your info, whether it be this, you're probably not Smokey Smith, but you need to grab your info and add it to the document over here. This is the point at which I probably put up my message. Brian's doing similar work to what you're doing, but is doing something different because I'm about to change up and not do your exact stuff. Zariah, Joshua, is everyone who's in the chat? Anyone here? Louie? We're going to start talking about how to make a regression. Let's start talking about that. So, Data Analytics 5. What's up, Zariah? Making the regression. Derek, good to see you. When do we make a regression model? I'm going to open up a data set here, but when do we make a regression model? When do we use regression? When do we use linear regression? Who knows when we use linear regression? Who knows when we use linear regression? I'm trying to find a good data set for this. Good to see you, Joshua. Oh, good. Here we go. When do we use linear regression? Hey, Colin's here. All the regressions. So when do we use linear regression? It is used to analyze the linear relationship between two quantitative variables. QQ, straight enough, no outliers, plot doesn't thicken. Exactly. For two quantitative variables, we can add a line to the data and see if the data follows the line, to what degree, and if we should do it. That goes to the conditions for linear regression. So notice right here, I have final high school GPA and current GPA. Once again, I'm not doing your work anymore. I showed you how to get your random sample. And now we need to do a linear regression. So what we should be able to do right here, and I think the instructions kind of walk us through it. Let's see what the instructions say. Right here. So we want to add a trend line, all this stuff to it. We're going to make an example chart like this. Look, it has the equation, has the r squared, has the intercept, has the slope coefficient, all this good stuff. And we're going to make this for our data with the line using Excel right here. Make sure to make a nice chart. So what you want to do is you want to make sure you select both your columns. So now you're going to click one column and hold shift and click the next. And now you want to go in here to insert. We're going to add in a chart, and that should be the scatter plots. There's our scatter plot. Look at that. It's not the best looking scatter plot I've ever seen, but it's the scatter plot. And there is our scatter plot. Once again, let's show the process of doing this. The process of doing this is to click and then hold shift. Then insert. Underneath the chart, scatter plot. So now we've added in our scatter plot, huge outlier down here. Might want to remove that if we were doing some big analysis. Well, QQ straight enough, no outliers. So big problem there. Pirate, I think I do. Are you from around the world? I think so. Good to see you here, Pirate. We're doing some regression analytics. And what we're going to do now to this chart is we're going to add a chart element, and we're going to add a trend line. So you see it says linear right there. Linear. We are adding the linear model to this. So notice we have the trend line added. We've added the linear model. And what we should be able to do to the trend line is we should be able to add the equation under more options, display r squared and display equation. Oof, look at it. It's over there. Good to see you here. I might try to, I think the Mac can be, if anyone can't find their thing on it, let me know, because the Mac can be a little bit weird. I want this to be bigger. Oh, I can probably just do font size increase on just that one. No, that's not that bad actually. And there is the r squared and the regression equation. If you're trying to find it on a Mac, let me see if I can make sure the Mac individuals can find it. It should be under chart design, add chart element, trend line, more trend line options. There you go. Mac can be weird. Exactly. It can be so annoying to get things added in. So once you've made this graphic, make sure your X and your Y are the right ones you want. And you need to add in titles and axis titles. So notice these things we can add right here. Make sure you have the right one on X, the right one on Y, and you add in the right titles. If it's reversed, you might have to copy a column to the next to each other's columns, because it generally picks the one you pick first, as I think, I can't remember if the X or the Y, but just append a column to the right by copy pasting and then make it work. So this would be, I believe, high school GPA. Actually, no, this is college GPA. Because college GPA has the 0 in it, from what I remember. And then this is high school GPA. So you need to label these. And then we would say college GPA predicted by high school GPA created by Brian Stevens. There we go. Look at that. There is our regression model. And once again, when you take pictures of this, do not take pictures of the full screen like this. That is not a good picture. That's not what you want to submit for your assignment. When you submit your assignment right here, make sure you crop in on the picture. You can always bring it down to where it is just what we want to see. Take a look at the example screenshots for how they should look. Your screenshots should look similar. You don't take the full thing like I did and then crop. Just do it right the first time. There you go. So this is the way things should look when you do the screenshots. They should look like a good regression model that you can accurately see. Don't worry if it has issues. You will talk about said issues when doing this right here. I think we do need to make a residual plot too, so we'll make that here in just a moment. Okay, so what you'll need to get the full regression output is the regression, the analytics tool pack. With the analytics tool pack, we can go in here and go to data analyze. Let me put this as a new note, analytics tool pack. Well, 33, data analytics 5, data analytics. Okay. So to get to the data analytics tool pack, you need to make sure you have it installed via the plugins. Then go to data, data analyze. And if this isn't here, make sure to download the data analytics tool pack via the plugins. And now you want to go to regression. So once you click regression, you're going to be prompted for your Y range, which the Y range for us is going to be current UT GPA. And then the X range is going to be final high school GPA. The labels are in the first column right there, or the first row, excuse me. So that's what it means by labels. We're not going to force the intercept to be 0. That's what constant 0 means. We're not doing confidence intervals, and we do want the residuals and residual. We don't want the residuals. That's a thing we don't necessarily need. We do want the residual plot, and I don't think we need a line fit plot. Let's see what we get. It's mad at us. It's mad about... Really? You want me to go in here and do... Wah! Let's go... You're going to get mad about that? There we go. That looks... Yeah, it looks right. And then change to R. Whoa! What's going on here? Why are you doing that? Okay, we're just going to select you manually. Click here, scroll down, click there. Okay, that should do it. Thank you for not making errors. I think the line fit plot would actually give us the linear model. So we could have done that too. I would stretch this out a bit. I would try to make this look presentable so it's easier to understand. I'm just going to rerun that really quick because I think the line fit plot, if you didn't get it, good to see you, Grace. If you didn't get the original plot, you could go back here and go to Analytics Toolpack again, and you could make, I think, the same plot we made originally with the regression. So if you go to line fit plots, I think you get that right. I don't love, and then you can't get the model. So that is the same model we just made, but you can't get the part we made just a moment ago with the required parts, which are all the way back up here. So that first part I just showed you is very important because you don't get the equation in there. You get kind of a version that's not as amazing. So that's this plot. These two plots are the same as in that plot right there, that orange dots, which why can't they add a line to it, is that dashed line right there. And you could also go in here and change this line to have a color that's easier to see or something. So you can always, update this, make it look a little bit different, and choose how you want to do it. So in the dots, well, I don't know if we can change all the dots at once. It's tricky. Okay, so now we have our output. I would not probably make that plot. If you did, just delete it. Your residual plot is going to be very important. And let's take a look. Let's take a look at the assignment. So once again, a title, equation, we've got all that added in. A screenshot, ask ChatGPT how to make it. We did all that. Regression output and residual plot. So notice here is the regression output you need. We just made that in Excel just a moment ago. So here is the regression output. You don't need the bottom components. Do try to make this look nicer. Notice how coefficients is kind of jammed up right there. You can double click any of these to expand out. And you could also reduce some decimals if you want. By selecting all the cells, you can go in here and delete down decimals, where we probably only need maybe 3 decimals is kind. And then this right here, you could reduce down. Oh, that's font size change. We don't want to do that. You could reduce down decimals, and the p-value is basically 0 right there. Yeah, there is the p-values, or basically 0. So overall, and then you could realign these a little bit more. Now you've got more kind of space in certain areas where you're running out of space, and it can better work for a screenshot. And these values also, I would kind of go down and delete some decimals on. I'd be like, let's say we only need to report to that many decimals. So overall, this is looking a lot better right now. How do you round decimals? Click the numbers you want to round, hold shift to select a bunch, and then go here to the add or delete decimals. This is add or delete decimals. Thank you so much, Joshua, for asking right there. So I wouldn't go too crazy. always add in like one extra than you think you need. It depends on what you're analyzing, but you could go 4 and you'd be fine. I would not go down to 1 decimal. That is ridiculous. Sometimes I go 1 decimal more than I think I need, so that'd probably be good right there. Like that's just depends on what are we reporting, what's the context to think about how many decimals you need. So you could bring these to 4 if you want to be consistent. You could be like, let me do 4 decimals. Just looks a lot better. And then you could be really like vigilant and be like, well, those are whole numbers, so let's make these whole numbers. So now if you look, the output looks a lot nicer. That's kind of the goal of this, is make the output look nicer before you do things. I would also go here and maybe add in a little bit of fill and make this look nice. So all we're doing is selecting the cells and adding in a little bit of fill to just give it a little pop. So they're way large. Yes, your numbers could be larger. Exactly. It just depends on what you're analyzing. So depending on how you want to round them, that's all you need to do. Just the rounding you choose to do. Let's do an inner. So I'm just trying to do some nice borders here. Make it look pretty. Make your output look really nice. The nicer you make it look, that's just good practice to be like, let me take a lot of pride in what I do. And, you know, this is just the border option right here to do the inside and outside borders. Could have just done lines too. There we go. And then we need to make this yellow. I mean, just think about how much better this looks right here. I guess what you could do, see, I'm always like debating how to do this. You could do this. I want to see how this looks. And then can we do like the lower bar? And then lower bar. Oh, I have to do, let's just do it the same way. We'll be consistent. So we do the inner one, all borders in, and then circular border out, and then grab the top and do a border. There you go. I mean, it looks a lot nicer, right? So with this right here, it's much easier to read. You could increase fonts if you want. I think if you grab everything all at once, you could make the fonts a little bit bigger. That is causing problems now. We'd have to resize everything. So we'll just go with this. This looks really nice, really easy to read. It's kind of the goals with this. And now we want to take a screenshot of it. I want to bring it over. And I always hate, well, I'll go with it. I want to get that border. You have no idea how crazy I would be about making this look perfect. I'm very obsessed with my graphics. But there's all the output. If you look, we now have the regression statistics. We now have the ANOVA output. And then we also want to grab our residual plot. The residual plot can be seen over here. I would make the residual plot bigger if it comes out scrunched like this. That is very hard to analyze. I would go here and analyze the residual plot following. Okay, so let's grab the residual plot. Get that nice clean screenshot. Drop the residual. I think we have everything we need now graphically. You want to organize this and make it nice and neat. But let's take a look. Okay, how's everyone doing well? We're going to go to some analysis right here. So that was good 6-7 minutes. And now we're going to do analysis of the regression. It's cold in Florida, no bueno? How's it cold in Florida? That's impossible. Craziness right there. It's interesting. Cold in Florida. So now we need to answer the questions. And if you look down here, professional write-up, name the 4 conditions and determine whether it passes or fails. I'll tell you this much. What I would like people to do, I always like people to go through here and be like, the 4 conditions for regression are as follows. And then when you list them, you probably want to write things like 2 quantitative variables. And then something like passes, and then give your reasoning, like the reasoning, you know, because da-da-da-da-da, passes because why? Well, this one's easy, and I don't want to quite tell you all of them. Well, I mean, make this a nice format. Make it so easy. The graders will be like, whoa, this was so easy to grade. I can see 2 quantitative variables passes. I call it QQ. So I call this condition QQ. You have to have it to make a scatter plot. By virtue of us making a scatter plot, they're both quantitative. High school GPA and UT GPA are both quantitative. Now we get to the straight enough condition. I got to be careful with all the words I use because I want everyone to write down exactly what I say. What is straight enough looking for? Here, let's talk about it. Straight enough is trying to analyze, does the line do what? Straight enough. Let's do graphic A, graphic B. If you can add a line to data, is it straight enough? Yes or no? If you can add a line to data, is it straight enough? Yes or no? If you can add a line to data, is it straight enough? Yes or no? Don't worry if you get it wrong. Throw some points. If you can add a line to data, is it straight enough? If you can add a line to it, is it straight enough? Correct, Soraya. Great answer. You can add a line to all scatter plots. Just by adding the line does not mean it's straight enough. Which of these relationships is stronger, A or B? Which of these has a stronger relationship? It should go between exactly what you want. If it's straight enough, then you see the line going through the middle of the data. Like this is the middle. And A is way stronger. Even though A has a correlation equal to 0 and B has a correlation maybe equal to 0.6, it's because A is a nonlinear relationship. And so the line is not going through the center of the data. The center of the data is there for all the points, and it only hits the center of the data there. The center of this data is generally where the line is at. So that's a very straight enough relationship that the line goes through the middle of the data, and it's well approximated by a line. Like this data is well represented by a line straight enough. And there's one glaring issue for mine, which I would obviously mention. I'd say the person who had a high school GPA of 0, is it definitely a what? QQ straight enough. What's the next condition? I'd be like, there is obviously an issue with this. It does not pass it. I would put like does not pass this condition because obviously there's a huge outlier here. So the straight enough, for the most part, the line is going through this. I mean, there's a little bit of weirdness down here at the end. I'm more concerned about this, the outlier down there. I would say my biggest concern is the huge outlier. There's not a huge issue with straight enough. I can't see a bend to the model that's so obvious. And then last but not least, we have plot doesn't thicken. So for plot doesn't thicken, you want to look at the thickness of the data, and this looks decent. Plot thickening is really bad when it looks like the following. And it could get thinner too. Like, it doesn't matter.
It doesn't matter!
If the plot were to get thinner, that would still be a plot thickening issue because we don't want to see the plot get thicker in different directions. So we don't want the plot to thicken. So overall, this has about the same thickness, where these over here have differing thicknesses. You can see it gets thicker throughout the plot. You want about equal thickness throughout, called homoskedasticity. So I would say this plot does not have major plot thickening issues because the strength of the model stays relatively consistent. I know there's an outlier down there, but that's kind of a one-off. That's an outlier issue, not a plot thickening issue. This, I know it's a little different down here, but we have limited data because the spread is a little bit tighter in that area. And you generally don't want to look too small of an area like, oh my gosh, there's a tiny spread right there. Well, it's 1 point. You can't tell spread from 1 point. I'd say overall, it's similar thickness with limited understanding at the start of the model, and the model doesn't really get stronger or weaker. This model is getting weaker because it's getting more spread out. This model is getting stronger because it's getting closer. So plot thickening, you want to see the model have about the same spread around the line. And a way to check it is with the residual plot. It's the same sort of plot we have here. You can see the model getting a little bit thinner there with the weirdness down here. Take a look at this drawing. You see how it has that and these orange bands. It's the same thing I'm drawing over here with those bands and the outliers. So if you see that drawing I have up there, see this one here? It's the same thing as the drawing here because it's the same plot. It's just that the line is flat. So a residual plot lets you see all the residuals and is generally pretty good for examining if there's some issue like plot thickening, which I would say there doesn't seem to be strong evidence of plot thickening due to, if I say that, everyone's going to be like, I copy you. Figure out your own way to word it. Figure out your own way to say it. Okay? So that's the conditions. The conditions. QQ straight enough. No outliers. Plot doesn't thicken. Explain them all. Explain if they pass or fail. Next, we're going to analyze the regression coefficients. What are the two coefficients of a regression? What are the two coefficients of the regression? What are the two major coefficients? We got a this and we got a this. What is the this? What is the this? Anyone know? So the regression line is the equation y hat equals b0 plus b1x. Exactly. Nice job, Joshua, right there. So b0 and b1 are the intercept and the slope respectively, and we can see them right here. This is b0, this is b1. And then going down a little bit further, you can still see b0 and b1 right here, where this is b0 and this is b1. So you can see the values right there. It's also important to note that the significance of the slope is whether or not the model is statistically significant. So that's going to be very important, which technically is also this value. It's the significance of the ANOVA, which we don't get into in our class, is still the significance of the slope. Another value of note is r squared. Let me put that in a different color. R squared is not r, though. R squared is not r. R squared is a percent of variation in y explained by the variation in x. And you'll notice right here, MuBot has interpretations in the chat for the r squared, the slope, and the intercept. So the slope is for each 1 unit increase in x, we expect y to increase or decrease by b1 on average. So for each 1 point increase in high school GPA, we expect someone's college GPA to be 0.21 higher, or 0.22 higher on average if I round it. So for each 1 unit increase in X, which is high school GPA, we expect someone's college GPA to be 0.22 higher on average. Wait a minute. Oh, because it put it first. Ooh, wait. Ooh, I wish someone had caught this error. Because of the way Excel does this, they did B1X plus B0. I do make small mistakes. Watch out. I don't plan to make more. But notice here I put B0 plus B1X. It's usually because we write y hat equals b0 plus b1x, but algebra writes y equals mx plus b. So just the small difference between algebra and statistics created that small issue where Excel went by the algebra format, and then my eyes deceived me. So b0 would be when x is equal to 0, we expect y to equal b0. So when someone's high school GPA is equal to 0, we expect their college GPA to be equal to 2.6651. That seems a little bit illogical because if you have no high school GPA, how'd you get into college? Your high school GPA is 0. You might want to comment on the logical, illogical nature of what you say. Like imagine this. When somebody weighs 0 pounds, we expect them to be 5 feet tall. Wait a minute. If you weigh 0 pounds, you're probably not 5 feet tall and you can't weigh 0 pounds. So make sure to add in if it sounds illogical. That can happen with the intercept because you're saying when x is equal to 0, we expect y to equal whatever the value of b0 is. So make sure you're interpreting it and then adding, does that make logical sense? R squared is the percent of variation in y explained by the variation in x, and MuBot has it in the chat right there. Blank percent of the variation in y is explained by the variation in x. So you times this by 100. 6.1% of the variation in college GPA is explained by the variation in high school GPA. 6.1% of the variation in college GPA is explained by the variation in high school GPA. Last but not least, this model is statistically significant because the p-value of the slope, which is how the line goes up and down, the p-value of the slope is below 0.05. And that can be seen right here. I think this has done the whole assignment now. We've interpreted the regression coefficients. We have done all the components of this. You're just AI reflection on how you used AI or didn't use AI. We should accept that either which way. I'm for if people don't want to use AI, be like, I refuse to use AI, just watch Brian's videos. I think all graders and everything should respect that. It's my view. I would argue that. I would say, well, is it my AI reflection that I don't use AI? That's my reflection. That's how I reflected on it. It's a valid reflection. Any questions? Anyone stuck on anything right here? And I would use MuBot right here. It says use ChatGPT, but make sure you use MuBot AI Tutor. He's going to more often have the better notes. A lot of people were using it last semester. I hope more are using it this semester. But any questions? We can go over to the assignments. Any questions? I'm trying to think about the pacing. Let's go to the base screen. Oh, man. So tired. I fall asleep so quickly at night these days. I guess that's a good thing, right? Just pass out. Chapter 12 is due then. 13. Yeah, we got a lot of 13. 13 is where people get stuck. And let me move the canvas content. We're going to do canvas content now. Well, if I move it, then people aren't going to see this. So we're going to move the canvas content. Yeah, let's do chapter 10 quiz. You got it. That is a tough one. Removing canvas content. Okay. Let's do the chapter 10 quiz. Need that third cup of coffee. All the coffee. All the coffee every day. Anyone else here addicted to coffee? Monster. I shouldn't have drank a Monster yesterday. I was like, I shouldn't do this. Shouldn't do it. I used to spend more money on campus. I probably spend less than $50 a semester now on campus. It'd be like $3 a week. Some weeks might spend $5 or $6. So might try to spend a little money. It's hard. Get hungry, get thirsty, even though I bring food to campus. Bring my food to campus. Got a bunch of food in my office. I don't think I can have a cooler in my office. I feel like I should. I don't think I can. I don't think I'm allowed to. So, bummer, right? Okay, let's go over here to chapter 10 quiz. I was getting it open in the background while we were talking. Okay, any specific questions that people are doing? Frugal, yes, very, very, very. Head over to the main screen here. Try to save money where you can. Ian knows what's up right there. I'll just say that is one of the best things. Don't drop a question in the chat and we'll do that question. But probably one of the best things I ever realized in life is that, like, simple pleasures are where it's at. Like, if you enjoy Taco Bell, occasionally when what is Bobby? What is that? If you enjoy Taco Bell, then what is so much better about a really fancy $200-$300 dinner? Taco Bell is more expensive these days, but back in the day, I used to go to Taco Bell for like $3-4 and get some like lava sauce. Oh, occasionally with Bobby. There's the question. Okay. Some lava sauce and everything like that. Oh my gosh. Lava sauce was where it's at. I could go to Taco Bell for under $5, come back with a sack that weighed like 3-4 pounds of Taco Bell stuff, and then just like feel amazing while eating it and then horrible after. Worth it. So, yeah, classic taco. Nacho fries. Or they had the potatoes too. The little potato thing you got was like $1, but that thing was like the best snack. Oh, this is Nate though. Occasionally when Nate. It's not Bobby though. It's Nate. Okay, we saved this one. Let me get the notes for today. Okay, here we go. I think this is the same one. I know it is. I've done this question. Okay. 41:13. Stat 201, chapter 10, occasionally quiz. Occasionally when Nate. Okay. So Nate is filling up his car right here. And what is the statistic he's calculating? Let's take a look. He figures out how many miles per gallon he gets in his car. He wrote these down after 4 fill-ups. And overall, he got 25.1. So what is the symbol? And I don't think it asks that, but let's ask it ourselves. What is the symbol he found? Does anyone know? He found 4.1 miles per gallon, or 25.1 miles per gallon. So what's the symbol he found? Which actually, I think this will answer it if we find the right symbol here. What did he find symbolically on here? What symbol did he find? From his fill-ups, he found like 25.1 miles per gallon. So what symbol did he find? Y bar, you're right, the sample mean, which I think is going to be the answer. He found the sample mean because it's a statistic from a sample. So he got the sample mean. So he got the sample mean Y bar of the gas mileage for his last 4 fill-ups on his car. What is he trying to estimate? Well, so what is he trying to estimate? He's trying to estimate which value? Well, it's right next to it. He's trying to estimate the true mean, mu, for the population. And the population of interest for him is probably his car. So he's trying to estimate the true mean, which is the population mean, of the gas mileage for his car. His results may be biased because why? Well, I want you to think about this. With the gas, we all know gas is going up. This is what's going on in the world. With gas prices going up, I'm taking a lot less trips. Like on the weekend, it's like I come to school and then I drive home. And so, because gas is expensive, frugal Brian, if you're here for the question. So we're not doing as much like country road traveling. So frankly, if I'm just traveling on like highways and stuff, I might be getting better mileage because depending on what you drive on, your mileage varies. So his results might be biased because his recent driving conditions may not be typical. So that would bias it. You want to see a typical driving pattern to get an understanding of how on average he gets his gas mileage. The EPA would be trying to estimate the population mean of the gas mileage for all cars, because they're not going to be concerned about Nate's car right here. It'd be for all cars of this make and model, and that should do it. There we go, 100. Another one. Drop another one in chat. There's one question done. So that's just dealing with trying to estimate the truth for a population. Populations differ. Nate cares about his car. The EPA cares about all cars. Why is EPA mean? Because they're trying to estimate the true miles per gallon of all cars, because maybe they're worried about like environmental standards. Are cars getting enough miles per gallon? So the EPA is trying to estimate the mean, the average of what all cars get to see the fuel economy miles per gallon. So they're still trying to understand like the average. They could try to understand other things like the percent of cars that meet a standard. So you could argue like, but could they be interested in another parameter? Whatever parameter they're interested in. Yeah, but this question kind of goes down that line of like the EPA is interested in the population mean of all cars on what they're getting on gas. Since it says gas mileage, the average gas mileage. Yeah. Does that make sense, Zariah, right there? And then drop another one. Drop some more questions in the chat. More questions. All the questions. Can't get Monster 2 days in a row. Not allowed to. There's tons of these questions. Lots of them. And if you, let me put this right here. So if you are stuck, you see it says here a local TV station. If you are stuck, I want you to do the following, is go over to the Stat 1 channel, which you're probably on right now. And so I'm putting this note right here on how to find any question. If you go over to the Stat 1 YouTube channel, you will see this little search bar right here. And if you type in a local TV station, wait, let's go here and say a local TV station. This is actually a tricky one. And then look right here, October 13th. October 2, we'll do 2 members of PTA next. You got it. And look right here, a local, and then we did the homework. So if you're stuck on the homework, here's the homework right here, the full homework done. Every question on the homework completed right there. So look at the little things you find. If you go to a local TV station, this one gets tricky at the end. It always makes me go crazy. It should be, don't skip ahead to the answer. See what I'm talking about. I'm saying, what's going on with this question? What's going on? But you can usually find the questions. But I do like going back through them. I don't want to just be like, go look at the videos. But then I know people are like, he didn't do the one question I had. He didn't do the one question. And then a lot of these exam questions can be, here we go, 2 members of PTA. So check out the videos. Usually I've got a help video on the question. If you can't find it, I'll help you try to find it. And Mubot posting about the website right there. So let's go mark this here. 4 to 6. 4 to 3. Stat 201. Chapter 10 quiz. My goal, I want to one day mark all these so you can like find them, like have a resource where you just click and be like, go to this video, Brian doing the question. Okay, 2 members of the PTA committee. Okay, 2 members of the PTA committee are proposing the accompanying questions be asked. Should elementary school age children have to pass high stakes tests in order to remain with their classmates? It should just be, I mean, that's a little biased. It should just be, should we have these tests? I don't know. So let's see right here. Do you think responses to, question 2. Should schools and students be held accountable? That puts accountability on students for meeting yearly learning goals by testing students before they advance to next grade. Well, the questions are going to differ. The answers for the 2 questions will differ because question 1 will probably get more no's because you're making it sound bad, like they get held back. So this is such a weird question. Question 2 may get more yeses because it's like, should be, yeah, an example response bias, because it's basically the same thing. Like, should we hold students back? And this is saying, like, but they're going to not be with their classmates. And then, should they be accountable? It's like, well, yes, they should be accountable. Or, no, they shouldn't lose their classmates. Pose a question with more neutrality. So, should students be held back for below average scores on standardized tests? That sounds pretty good. Do you think standardized tests, is it appropriate to use standardized tests to raise students' intelligence in order to decide whether a student, see, that's like, this is a philosophical thing. Like, we're not really rating students' intelligence. We're seeing aptitude. And yeah, it's like, is it appropriate to do this? No, that's biased. Do you think standardized tests should be used to determine if a student is capable of handling the material taught in next grade? That's still kind of like, putting it on the student. I'm not saying, it's just like, oh, these students aren't capable. It's like, well, we're seeing if they've met certain standards. It's the way we're phrasing it. It's so hard to make a perfect question. Do you think standardized tests are appropriate for deciding whether a student should be promoted to the next grade? Between A and D. Should students, why not D? Do you think standardized tests are appropriate? Just the way it says, like, we should just be, whenever you ask questions, you want to put as little baggage on it as possible. You just want to say, like, I think it's best to just be like, should students be held back? Because it's getting at that. Managers of large companies next, you got it. Should students be held back for below average scores on standards? It might be D. I might be wrong, Soraya. Oof. Soraya, I think you figured it out. Soraya, we're throwing you some big 20,000 points. I was debating it. Once again, maybe not one of my favorite questions here because I got it wrong. I was like, I feel like you could be right, Soraya. I should have went with it. This is a very ridiculous one. I don't love it. But now you've seen the answers, so now it's a freebie. But it's just getting to response bias. You should know what response bias is. Response bias is when the way the question is worded or the way the person acts somehow influences someone to go in a certain direction on a question. So some of these are worse, like, is it appropriate to use standardized tests to rate a student's intelligence? No, we're just asking, should students have standardized tests to advance to the next grade level? That's probably the best way of doing it, which sounds like this. Do you think, I don't like the appropriate. Should standardized tests be used to have students advance to the next grade level? Maybe it's the held back has loaded language in it. But I mean, I guess it's so debatable. Like, I'd love for 100 statisticians to look at that and say which one has the least response bias. Managers of a large company. Let's go find that. Drop more questions. We put them in order and we do them. Major League Baseball one. Managers. Here it is. I think this is it. You're welcome, Ryan. Thank you so much. Sorry I got one wrong right there. It happens every once in a while. The managers of a large company. Here we go. 50, 53, Statute 1, Chapter 10, Quills. The managers of a large company. Wish to know the percentage of employees who feel extremely satisfied to work there. The company has roughly 39,000 employees. The company is considering ways to survey their employees. For each of the designs below, identify the problem. I think you only select one in these boxes, if I remember correctly. Leave a stack of surveys out in the employee cafeteria so they can pick them up and return them. That is going to lead to a lot of problems. Not really response bias. It's not that there's no problems. It's probably going to be convenience. I want to cheat and look at the answers, but we'll give it a shot. Let's probably get it wrong. Consumer Magazine next, you got it. One of these I think is convenience. Wait. Oh, and then we pick, yeah. So it's it is too. I was like, I knew it. So design would have voluntary response bias, and it's also convenient to just leave it out. That's why I was like between these. I was like, I want to get it right. So this is where I get mad at these questions sometimes, because this design would be a convenience sample. Identify the problem with design. Why? I don't get it. Sometimes I don't get my Pearson's logic. Sorry about that. It drives me crazy. So the design would be a convenience sample, suffer some voluntary bias, and would have voluntary response bias. So the way they phrase it, a little bit crazy right there, a little bit crazy. So one of my least favorite quizzes of all, one of my least favorite quizzes. We need to do an overhaul on it, in my opinion. Redo the quiz. This one. It's just a few questions that are just ridiculous. A consumer magazine. Those change up a lot. Those change up a lot. Wait, is it this one a US? Is it the US Logan right here? Is it this one? Is it question 12? Is it question 12? Let me know if it's question 12. Oh, it is. Okay, good. Okay. So for these right here, these are also one of the ones where sometimes it says like it's unclear. But let's talk about this and not answer the questions yet, and then we'll look at the answers. So if you notice, it says a U.S. consumer magazine asked, well, let me retimestamp this. Okay, it's right here. There we go. So this one is about a U.S. consumer magazine. It wants you to go through the population, the sample frame, the sample, how they sampled, and any sources of bias. Now, some of these are pretty tricky, so I suggest watching some of my videos on these, but I want you to try to answer these questions with the terms before answering it with their terms. So first off, when you think about a population of interest, it's every person or thing we want to understand. So a U.S. consumer magazine asked all adult subscribers, sounds like they want to understand all adult subscribers, whether they had used psychiatric medical treatments, and if so, whether they had benefited from them. So they're interested in have people use psychiatric medical treatment, and that is a parameter. Sometimes they put down here it's unclear, but it's probably going to be the proportion who benefited from who've used and benefited. So it's probably going to be these. It's also going to be probably, I hate to say it's probably going to be unclear, but all adults. They want to understand adults. So you don't see the subscribers in here. So I'm thinking E for this, and then the proportion you use it. You were doing a say you got it, right? We'll do the next one. What is the sampling frame? The sampling frame are the people they have access to. So don't read their answers. This is where you want to practice. So the sampling frame would be the people they had access to. The only people they have access to talk to are the people who are subscribers of their magazine. So obviously it's going to be subscribers to this magazine, all subscribers to the consumer magazine. Yeah. Not that they will respond. Who is the sample? Anyone who responded. Anyone who took it. It's not everyone who is a subscriber to their magazine. It's anyone who took it. What sampling method was used? It's where it gets a little iffy. It seems like they kind of did convenience. I might even go unclear. That's where I get a little bit mad about this, because I might go unclear. Is the sampling method used random? I think they're going to go yes here. And they... wait. It's not really random because they got just their people. Because look, who was left out? Those who are not subscribers to the consumer magazine. People who are not subscribers who were left out of the study. What type of bias is there going to be? Definitely under coverage. Since they left out people who don't subscribe, the people who don't subscribe might feel differently because they're subscribed to a psychology magazine and this is about psychological treatments. So we'd have reason to believe there is going to be under coverage. The people who we left out of the study might somehow differ. And so we've got here 2, and 2 is only paired with 4. Non-response. I don't see large people not responding, and I don't see, you could argue voluntary, so I would just go 2 here. Let's see how our answers look. So unclear, but probably all adults. We said that one. How they benefited. All subscribers to the magazine. This is all the people who responded to the survey. And voluntary. So that is not random. I said unclear for this one. I would have got that one wrong. And those who are not subscribed, we said that one. And then we said only 2 for the last one. 1 and 2. Oh, because it's voluntary. So since they're saying it's voluntary. And I guess they are asking people to volunteer. Yeah, and people with strong opinions were more likely to respond. Makes sense. It's a little bit of convenience too, but I think they didn't list convenience, did they? They did put convenience. It's one of the trickiest quizzes. We try to make it as clear as possible when we do the test that it's voluntary sampling, that we would say something like, people were asked this question about politics, and like the people who responded were really interested in it. So that's going to be voluntary. Voluntary sampling has people with strong opinions. Convenience goes with how you set it up, which you can argue this to be convenient because it's like they went to their subscribers. The one we just did a moment ago was about people putting a survey into like a lunchroom. That was just convenience. It's not a good way. There's another one which talks about putting it in mailboxes. That's just a convenience survey right there. Like you're just doing it in an easy way. So sugar candy, oh man, you were doing a study on a nonprofit. Let's try this fun. You were doing a study on nonprofit. Does sugar candy say it down here, John? Or Joshua, excuse me. Thank you, Logan. Ugh. This is one of the best ones to watch office hours on because this is tricky. And you were doing a study on nonprofits. If you see your number, let me know. That's so easy. Look at this. Look at that. 50, 50, 50. Strata. I just see something that I'm like, I know stratification. Oh, here we go. It's similar to pretzels, A through G question. Yeah, that's what I thought. Yeah, those are like production questions. Yours might be easy too. You're doing a study on nonprofit. Suppose you know that 14.2% of the state lives in poverty. So that's something you know. So which off the list is that? If you know 14.2% live in poverty, which value is it on this list, Soraya? You know 14.2% live in poverty. No worries, Soraya. Let me put it on here. If you know 14.2% live in poverty, then what is it on this list? If you know 14.2% live in poverty, which one is it on this list? So you know this is a fact. It is the proportion. You're right. And be more specific. You're right there. 5,000 points. You're right there. It is the proportion, but which one is it? And you know this. You know 14.2% live in poverty. So you know this is a fact. It is P. Yep, because it's for the population. So that's the important part right there. It's P. It's a population parameter because it's a truth. And so this would be a population parameter. Exactly. There we go. Good question. I like doing those little easy ones. They're fun. And always, you want to know the easy ones before you click the answers, because then you're like, it's a population parameter. And they're like, oh, yeah, it's P. It's a population parameter. And you get it like that. And that means you know it. You're well at 5,000 points. Thank you for being here. Get those A's. You got this. So, no, like, people mess up the easy ones. Watch. How many things have I gotten? I teach the class. Let me throw you another 5,000 points. I teach the class. Might have missed one or two today. I've been doing these quizzes for 15 years, and I still can't get 100 on this one every time consistently. So someone's like, well, what do you expect me to do, Brian? It's a tough quiz. It's very nuanced. It's so nuanced. Because I don't do sampling my whole life. I do stats. I do numbers. It's very important to do sampling, but so nuanced. We got the sugar candy one, similar to pretzels, A through G. Oh, here's the pretzel one. We just found it. Okay. Company packaging pretzels. I think this will be good, right? Because if you notice, when you change it, will this be good here? Not Logan. Joshua, is this good? Is this a good one right here? Is it similar enough, or we could try to find the other one? Okay. And if it's not similar enough, let me know. It should be very similar. Okay. Company packaging pretzels maintains quality control by selecting 10 cases from each day's production and weighing the bags. Well, that's going to be their sample. And the cases sound to me like clusters. And they mentioned like a multi-stage here. They open 4 random bags within each case and expect the contents. So they're kind of kind of like a multi-stage-ish, because they're selecting 10 cases and opening 4 within. So yeah, what is the population? Everything they make. It's all the pretzels they make. It'd be all the bags. Should be all the bags produced by the company. The employees, no. Consumers, no. And it's not the sample. That's the sample. Parameter of interest is kind of unclear, because it's definitely unclear for this one, I think, because they're just inspecting the contents. What are they looking for? Like the weight, defects. This is about the most unclear it could be. Now, the sample frame is where people make errors. The sample frame is going to be the things they have access to. So it's going to be all the bags produced by the company each day, because any bag that day could be sampled. Does that make sense? So I'm pretty certain on this one, because the sample frame is everything we have access to sample. So any bag that day could be sampled. What is the sample for the study? It is going to be the 40 total bags opened, not the 10 cases selected because they're not taking data on everything in the 10 cases. The 40 total bags opened are going to be the ones used. So there's 4 bags selected at random, 10 cases. I think this is a multi-stage because they're going and there's simple random sampling. You see stratification was used. I'm between strata and multi, and they're selecting 10 random, and they're not taking everything in the case. So it doesn't seem like a cluster to me, because when you do cluster sampling, you do a census on the clusters. So if they were to take 10 cases and take every bag in the case, that'd be more of a cluster, but it's probably stratification. If not, it's going to be multi-stage. I'd hate if they do unclear because that's just kind of mean. Randomization was definitely used because it says right there. Nothing should be left out of the study because they're doing a really good way of doing the study. They're just daily checking their work. So no group was left out of the study. And there should be no bias because they're not doing this in a biased way. The only one I'm worried about is the sampling method. We went with stratified. I'm going to go with stratified. And it was a multi-stage because they want to do that. And randomization was used. Nothing was left out. And the bags of the pretzels by the companies, the population of interest, as we said. Parameter of interest was unclear. We mentioned that because they're not saying what they're inspecting about the pretzels. It would have to be, don't read their answers. Always come up with your answer first, especially for these, to see if you know it. Sample frame would be all bags produced that day because they could access any bag produced that day. What is the sample for the study? The 40 bags, which they took data on. Sampling method, it's like a stratification by case. They're taking representatively from each case, but then they're also not taking from every case, so it's like limited stratification. It's just a very... I wish they mentioned what the multi-stage was, because it makes it a little confusing. But that's got that one. We'll see if... We might be able to find the sugar one, too. Can we find the sugar one? Sometimes Brian doesn't have his caffeine. Sometimes I can't even find, like, the sugar one. Pretzels! Lettuce. This one also is like, the thing is undefined. I remember, like, what is the parameter of interest? It's not, it's undefined. It's like they're looking for contaminants. Well, you think it would be like the presence of contaminants. Like, that is the logical thing on this one, but I've done this one more than enough to know that is not the presence of contaminants. It's like, well, I mean, because then you can argue, like, are they looking for the proportion that have contaminants? Like, what proportion are contaminated, which would be P? Or are they looking for the amount of contaminants, which would be mu? So you could argue that. Are they looking for the variation in contaminants? Like, is it like all of them are contaminated? That would be like a standard deviation idea, so a sigma. So I get why they're saying it's unclear. I think it's kind of unfair to ask questions that have unclear answers. It could say something like, which of these is unclear? Like, we are trying to find out the contaminants, or are we trying to find out the average contaminants? Well, very clearly, the average contaminants is very clear on what you're trying to find. So, what other questions do you have? We've done a few of these. We've done 1, 2, 3, 4, 5. We've done like seriously. I'm not even kidding. Sometimes you think I'm joking. 1, 2, 3, 4, 5, 6, and then we did this. So, yeah. What other ones? What other question? You're trying to study the amount of financial aid students receive. You sample 50 students. The average of your sample is Y bar, the sample mean. Sample statistic. You bought short-term memory? No. This is easy one. Who'll do this one for funsies? I like short questions. They're nice and fun. And then always try to know the answer before you look at the answers. The more you know answers without having to look at the hints, the better you do. Okay. Select several dormitories at random. Collect everyone living in the selected dorms. Wait a minute. That sounds a lot like a census. We took some amazing notes today. Amazing notes. And you'll notice them right down here. We listed out the ways of doing these samples. Yeah, was it this week's? Oh, we could do that too, Zerai. I did move it from this week. So here's our notes on how to do each sampling method. And if you notice, it said select everyone in the dorms. That falls under the do the census, which has to do with clustering, the C of cluster, the C of census. And so this is definitely a cluster sample. This one acknowledges differences. Notice how it starts by saying you're going to collect 100 freshmen, 100 sophomores, 100 juniors, 100 seniors, and you're acknowledging differences and sampling in accordance to those differences. So that's going to be a stratified. Every 60th right there is clearly systematic because systematic has the element of every kth observation. So when you see every blanked observation exactly, you have to, generally speaking, I would say generally, like we could do trick questions. Like, Zariah, you're basically right, but I could like try to trick you by saying like, you want to understand everyone on campus. So from everyone in your class, you talk to 10 random students, and they are the first you see. Oh, wait. Talk to... Okay. What sampling method is this? You want to understand everyone on campus. So from everyone in your class, you talk to 10 students, and they are the first you see. So who knows what method this is? So I'm trying to trick you by putting everyone in here. So what sampling method is this? And I removed random. That's kind of a hint because I removed out random on it. I was like, well, that's not random. You talk to the first 10 students you see. That's kind of the basis of this. Convenience. Yep, this is convenience sampling. So convenience is when you do things in an easy way. More voluntary is when people have strong opinions. So this didn't really get to the opinion nature of it, that someone's going to be like, oh, I really care about this. That's voluntary sampling. When people with strong opinions are more likely to give their opinions. Convenience sampling is when you do it in an easy way. So even though it says like everybody, and great job, Grace, right there. More questions if you have them. We'll try to do maybe one or two more. But we've done a good bit of the quiz. We got to look at all this stuff we got done today. Look at all this. Look at these office hours. Good stuff. Thank you to everyone who watches these in the future or currently. What should we do? Should we do one more? Get it done, go on a walk, and eat my peanut butter and banana sandwich. Off topic, but who did you... I didn't. I couldn't find my Disney login, and I didn't do it. I don't think... Okay, let me see if I'm logged in on this computer. Wait. If I am logged in, I will go do it. Because I got until noon, right? Well, it looks like I'm not doing it. Let me see. Checking the website. That would be convenient. Should be convenience. I know, right? We can't check the safety of this website now. Please check later. It's supposed to be safe. ESPN. I know, right? Exactly. Like, I look around and I'm like, well. No, it's got it. Kahoot. Well, I'm going to take a break. We've got a lot done right now. Grace, great job. Zariah, great job. Any last questions or thoughts? If I had to pick someone for March Madness, I hate to say it. It's not because I like them. I'm going Duke. I know Duke is a 1 seed. I saw that top left corner of it. You're welcome, Zariah. So I'm going to go Duke. I know Duke's won quite a few. Duke's got that history of winning. I'm not a Duke fan. Not a Duke. What are they? The Deacon? What are they? I don't even know what Duke is. They're over there in North Carolina. So I'm going Duke. And I'm saying Tennessee makes it to the Elite Eight. We're the Cinderella team this year. Tennessee makes it. You can show this later. Say, Brian, you should have filled out that bracket. Here's my bracket. I'm just doing one thing. Tennessee, Elite Eight. We get knocked out Elite Eight against... I can't even think of who's on our side. A&M's over on the left side. I know that. We're over on the right. We're bottom right. We get knocked out against UNC. Maybe they're over there. I don't know where UNC's at on the map. I don't even know if we can play UNC logically at that point. Although I'm picking Duke, but I'm from Ann Arbor, so I picked Michigan. Nice. Yeah, it's, those 1 seeds are what everyone usually picks. So, I mean, it's what you go with sometimes. But I'd love it. I want us to make it to the Elite Eight. I don't even know if we can play UNC. I don't know if that's a possible matchup at that point. But I'm saying UNC makes it far. Maybe at some point we see UNC. My 3 predictions are, here's my 3 predictions. My 3 predictions are, at some point, UT sees UNC. UT makes it to the Elite Eight, and Duke wins. Let's see how many predictions Brian gets right. With that, bye for now, everyone. Bye, Chris. Bye, bye.